Yep, I think we're good.
OK. Let's get started. I'm so glad to see all those familiar faces. I'm Chigusa Sansen. I'm a product manager lead working to provide client platform solutions to Windows app developers like yourselves. I've been with Microsoft for over 2 decades, and more than half of that has been spent in XAML technology area. And I'm very excited to talk to you about the 2 XAML technology that with Jeff, who I have worked so many years together.
Thanks, Chigusa. Hi, I'm Jeffrey, and I'm an architect on the Windows UI stack. I've worked on everything from Windows XP's logon to Media Center's rendering engine to creating the Windows UI composition APIs. I'm really excited that we're here to share today about how we've modernized the technology inside WPF and WinUI and how both XAML-based UI frameworks can build great Windows 10 and Windows 11 applications.
We have folks who are answering questions on Pebble, tough questions you can ask my own boss, Mick, and Naveen, who came all the way from India to talk about WPF. So if you are building Windows apps, you might be using one of those client technologies already. Microsoft supports and invests in all areas of ecosystem, all the way from Windows native to web.
Hey, Chigusa, is there any place where I can learn more about this?
Yes. As a matter of fact, I've created a deck with links to all those technologies, but I put it at the end so you pay attention to this talk. But if you must, please visit learn.microsoft.com. This talk is focused on 2 technologies to build great Windows native experiences. By the end of this talk, we'll learn what's the strength of each of those technologies and when to choose one over the another. The short answer is both WinUI 3 and WPF are great choices because they are invested in and actively developed. Knowing their unique strengths will help you with addressing your app's unique needs.
So let's get started with WinUI.
For context, WinUI originated from UWP when we were reimagining Windows ground up. Through Fluent Design System and Windows 11 update, WinUI was widely adopted, and now, today, it's the technology of choice for us to be building new features on Windows, including the Windows Recall experience you saw yesterday at the keynote. We have updated fundamental architecture and optimized it for modern experiences and latest hardware. If you need more flexibility in language choices and CPU support, WinUI is your choice. WinUI embodies Windows system natively with built-in usability to support all the input experiences that you are expected to support on Windows.
So what do you recommend for UWP apps that want to take advantage of new technologies like ARM64?
Yeah. So first of all, if you have UWP apps, it continues to work. However, if you want new features, WinUI 3 would be the easiest migration option for your UWP apps moving forward. And I want to clarify one thing. When we talk about WinUI in this talk, we are referring to WinUI 3 and not WinUI 2, which is for UWP.
So more generally, what if I'm new to Windows app development?
That's a great question. WinUI is a great choice if you are starting new or don't know where to start on Windows. We've updated Visual Studio Workload so that when you're creating a new Windows app, we give you WinUI as the default choice, and you can get started in no time. And this is available with VS 1710. Yes. And we've also improved File New Project. So basic support like title bar works as expected with the system theme and Snap Assist. So you don't need to write additional custom code to do that. And this is available with Windows App SDK 1.6 late this summer.
Let's get started with the WinUI demo.
Let's do that.
So we're going to start off by showing some places that we're using WinUI. Then we're going to show using the WinUI gallery to help me build my WinUI app. We'll show using both C# and C++. And then we'll show running our app down level to be able to reach 1.5 billion Windows users where they are today. This is just an overview. We really recommend going to the BRK 244 talk tomorrow. They're going to be going into more detail about all the stuff that we show today. So with that, we're going to start off with photos. So this is one of our great apps that's written in WinUI 3. And we can see it has a great scrolling experience. And this is all a bunch of investments that we've done in the last year. And then we took this and we brought it to File Explorer in the new Gallery tab. So you can see you get the same great experience. This is also implemented using WinUI 3. So how would I go about building this? Let's take a look. So in this case, we always point people to the WinUI gallery to get started. Why is that?
Yeah, we want people to have one place where they can find everything from code samples to documentation. So whenever people ask us, where do we find out about WinUI, we point them to this gallery.
OK, so that's why whenever I do a search, it always points me back here. So if we look at the gallery, how can this help us be a tool for developing my app? At the top, you see a bunch of resources for being able to go get more information. We then have the recently added samples. These are samples that are newly added to WinUI Gallery in the last year in WinApp SDK 1.4 and 1.5. You have the recently updated samples. These are samples and controls that may have been in the gallery previously, but we've gone and added new functionality. So please definitely check them out. In this case, for Photos and File Explorer, these were examples of using the new Items View control. So items, I can see like this looks like the photos that we were seeing. So the Items View control is been designed to be able to handle a bunch of different objects of different sizes and layouts and everything, and to be very efficient for handling very large lists. We also saw an example of the annotated scroll bar. So this is that scroll bar that I saw on the right-hand side with different labels at different points, where I could actually jump to different things.
So if I want to build an app that's like File Explorer, Photos experience, I could come here and look at some things that they implemented.
Yeah, so this is an example of the controls, but let's actually look at how I can get some sample code into my app. So right here on the source link, everything is in open source on GitHub. So if I click here and I go to XAML, then this takes me to the XAML that's used to actually implement that page in the WinUI gallery. And this is a great place to start. And then I can also see the code behind is for the C# that I have right here. Both the Items View control and the annotated scroll bar are implemented on our new Scroll View control that's implemented on Composition Interaction Tracker. And this replaces the older dmanip Scroll Viewer control. So what is this all about? At the end of the day, with Scroll View, everything can be customized, from the animations to object recycling in my list to programmatically manipulating the control. In this case, I have a bunch of photos here that I want to, when I click the scroll with animation, it's actually building a composition keyframe animation to jump to different places in that list. So this is very easy to do with the new Scroll View control, and it would have been much more difficult to do with the older dmanip Scroll Viewer control. So how can I actually use this in my app? So in this case, what we're going to do is we're going to use the Contoso Studio app that is going to be used in more detail in the BRK 244 talk tomorrow. So in this case here, I have Contoso Camera. And I'm going to run the app. And we've gotten some usability feedback on this.
Mm-hmm. Yeah, so what we found out is that people click on the disconnect, and they are surprised that they weren't given any warning that they are losing some work.
Yeah, and so I think you had mentioned that we wanted to add some UI in here.
Yep.
So let's see how the WinUI gallery can help us out with that. So if I go back here to home, I can see that there's different collections of objects. So I can see like things like basic input and collections. Oh, we already had that typed in from before. So we'll go to content dialog. And I think this is when we were talking before the session, this is what you had recommended that we take a look at.
So user can take an action to be able to cancel.
Yeah. So what did you want changed about this? I can't quite remember.
Yeah, I want to simplify this UI, make it 2 buttons, and then take
Get rid of the content
part,
in the middle? Okay. That makes a lot of sense. So let's see how we can do that. So in this case here, I expand the source code. I can see that the XAML that's here is the content that's inside the content dialog. So I think that we can ignore that. And the C# here, this is the code that looks like it's invoking the dialog. So I'm going to just go copy it. And I'll go over to my Contoso and device info control. This is where that disconnect button handler is. I'm going to go and paste this in. This should be pretty simple. And then I'll change the title. Disconnect from camera. And then you wanted this to say disconnect.
Yep.
And get rid of this button. We'll get rid of the content. Change this. IntelliSense. Primary is that first button that's getting selected. And then I'll move the previous disconnect code inside. And then, it's a wait. So I got to go modify my function so that it's async. And WinUI totally understands this, but if I had complicated code, I might want to harden my code while that asynchronous function is going on. So in this particular case, does this all look good? We'll try it out.
So now user is able to say that they actually meant to click on that button.
Yeah. Okay. And it's deploying, all real time. Okay, so I clicked that disconnect, and I got the disconnect from camera. If I click cancel, then the user sees they didn't lose any work. And if I disconnect, then it goes through and does that.
That was very simple, especially for those people who are not familiar with the XAML code.
Yeah, really easy way to get started. So everything that I'm doing here in C#, I also can do in standard C++. So this is just C++ as it is on all platforms, and we use CppWinRT for being able to generate the APIs that we're calling here, but there's no changes to the language. So this is C++ that everyone has used. And so I can see it's very familiar with the C# code. I can go and set the properties and invoke the method, and it's all pretty much the same. There was one other thing we were going to show. What was it again?
We want to show it running down level.
That's right. Okay. So here we have a copy of Server 2019. So that's like about 5 years old now. Mm-hmm. And we recognize that like some places are using this, and it's really important for them to be able to run the same app on all the machines in their entire enterprise and all that. And so one of the things that we have here is we have the latest WinUI gallery that's running, and there's no OS servicing, there was no updates, it didn't have to be an admin to install. And so I can see that content dialog is still here. Content dialog, and we can see it's right here. And that's exactly the same. It looks pretty much the same, but there's a couple of differences. What's up with that?
Yeah, so the window doesn't have a rounded corner, and then also some of the materials are not there because we didn't introduce that back then. But the developers didn't have to do any special coding for that.
So all the behavior of everything in WinUI 3 is the same running down level to all the versions of Windows, and it has all the latest features and all the latest bug fixes and everything. So it gives consistency everywhere. And then I think I have our Contoso camera app here as well, and it's all running too. So, okay.
Great.
So with this first demo, Back? Okay, so just really simple to get started. We showed the WinUI Gallery as a dev tool to help me go build my app. We showed my app can be written in C#, and we're going to support .NET 8, and that's really great. And I can also use standard C++ with no changes to the language. It's just the same C++ that exists on all platforms. And we showed it running down level to all 1.5 billion Windows users on Windows 10, Windows 11, and Windows Server.
So one of the feedback that I hear often is that WinUI is not so performant. Can you address this elephant in the room?
Yeah, so we did a lot of improvements over what you just saw with the photos and File Explorer. So we made the items view, the scroll view, and tree views work really well and have great scrolling performance that you saw. But we also did work with flyouts and resource lookups. The example is, like you said about the Photos team.
Yeah, Photos team achieved 2.5 times faster up launch and image loading.
Yeah, and then with .NET 8, that we're going to be supporting in WinApp SDK 1.6, that's what, late summer?
Yeah, in September timeframe. Yeah.
Yeah, we fully support .NET 8 AOT, the ahead-of-time compilation, and we've noticed about, for real-world large apps, we've noticed about 45% smaller distribution and about 50% faster launch time. And one of the things is that the AOT only needs to be applied to the C# code in your app. All of WinApp SDK is itself native, and so this means that you're only AOTing your app itself. So, and we've noticed substantial improvements there.
So now that you heard what we think about WinUI, we want you to hear directly from our partners to find out what they think about WinUI and also about WPF. Why did they choose one over the other? So let's take a look.
For Microsoft Photos, we chose WinUI 3 since it's a natural evolution of UWP. We can still use the beautiful UI controls from Windows SDK, and at the same time we will unlock new features and new possibilities, since now Photos is a full desktop application.
It's hard to hide my enthusiasm for building under WinUI 3. I've always felt that if you can build a native application, you almost certainly should. You're going to get the best performance, you're going to have full APIs available to you, and you can code your way out of any challenge presented. Couple that with the power and elegance of XAML, and literally anything is possible.
Performance is one of the critical factors for enterprise applications. WPF, with its native code execution and hardware acceleration now through RDP as well, offers excellent performance for applications, particularly those that require high-speed data processing and complex UI renderings. While newer alternatives have made strides in this area, WPF's performance remains still a reliable choice for the enterprises.
Many other applications developed by Microsoft, but also developed by the community, are in a similar position where there's an application that people have come to know and love, and what's the best way to bring it into the future when it has a really long feature set. So with XAML Islands, we were able to replace parts of the app with modern UI, while not bifurcating the app experience and having people need to go into either something new and wholly different, and then occasionally needing to go back into the old application when the new app wouldn't have some feature that they would need.
At the time, we took a fresh look at the options we had and considered approaches with Electron, with Qt, and with using Rust and Swift. I'm really pleased that we recommitted to C# and WPF. We've been able to move rapidly with Camma, brought a number of innovative features to Windows, and above all, we haven't been surprised. Well, maybe we've had a few surprises. ARM support was so easy that it was nearly free, and our path to supporting NPUs was easier than I anticipated. The surprises have been positive. C# and WPF are robust, mature, and well supported. We've been able to focus on building our product rather than wrestling with frameworks.
We are so grateful for partners and community members who are willing to work with us through trials and errors. We will not be here today without your support, so thank you very much. Both Photos and File Explorer chose WinUI to align closely with Windows design. Kahua, like many other partners, understands being native is important for Windows, apps, and they chose WinUI.
Now that we've learned about WinUI, what can we share about the benefits with WPF?
Yes, WPF has been around for many, many years. Partners like Morgan Stanley and Reincubate has huge investment in WPF, and they love the reliability and stability of WPF. It has vibrant ecosystem with rich and stable support of middleware and apps. It will surely help you to create great Windows apps. Not to mention the documentation and tutorials that we've built over the years. WPF has great .NET framework support, as framework itself is written by C#. We want to meet where you are with thousands of lines of code you have already written. Whether you're writing a simple app, line of business app, or client-server heavy apps, if you are happy with your investment with WPF, there is no need for you to switch. We want you to continue investing in WPF with confidence.
So why don't we show a demo of WPF?
Yes.
In this case, we're going to show the new WPF gallery that we're building as part of .NET 9. And this is available with Preview 4. And then we're going to take a WPF app that exists on GitHub, samples, and that exists as it is right now. And then we're going to go update it to show how it can get this new look and feel.
Yep.
OK.
And Preview 4 is available now, so you can go out and try.
So this is the WPF theme gallery that's available now. And you can go and see, this is really cool. So I can see this looks a lot like Win11, right? Like we worked really hard to make it look and feel just like everything else in Windows 11. This is a great update. So let's see what's involved in bringing that into my app. So in this case here, I have the calculator app. And this is just on GitHub, open source, and WPF samples today. We didn't change anything about it. All we did is just compile it just for saving a bit of time. And it's looking, what's the word?
Little dated.
It's a little dated. It needs to be updated. So let's see what we need to do. So in this case here, I've already gone and loaded into Visual Studio. And I've gone and loaded the project. And I've made the changes. And this is what I had to do. So I went into the application resources, and I put this funny-looking string, this WPF syntax. There are 3 commas in this. They're going to go into more details about this with BRK 244 tomorrow, but it's really just that easy. And so this is bringing in all the .NET 9 themes that allow us to be able to run on Windows 10 and Windows 11 with all this look and feel. So let's actually go run this. So let's see what this looks like.
Wow, that looks like a system calculator. And
yeah.
That's great.
Yeah. So we're going to come back to this app. So just another quick demo. And so we showed the WPF gallery with Windows 11 theming that's coming as part of .NET 9. And when is that going to be available?
Yeah, it's going to be available in November.
OK, and then they have progressive releases leading up to there. So it's something that you can go and try today. And then we showed a WPF app or a WPF sample before and afterwards with themes, and looked really cool.
Yeah. So let me summarize what you have heard so far. You want to choose WinUI if you don't know where to start, or would like your app to be aligned both visually and functionally to Windows system. If you want to be on the cutting edge of what Windows Evolution has to offer, and you want multiple languages and CPU support. Whereas WPF would be your choice if you already have invested in WPF, love the stability and rich ecosystem over being absolute latest, or you prefer working with great C# support.
So one of the things we hear is, I'd love to use this, but there's some problems.
Yeah, so whenever we tell a story like this, we hear that it sounds great in theory, but not in practice. For example, developers cannot afford to rewrite the whole app all at once. Or apps must support multiple OS with the same behaviors to reach most of their customers.
Yeah, I've also heard that app developers need to be able to control when their dependencies get updated, and they don't want functionality changing out from underneath them if they haven't had a chance to go and verify their own application code. So let's step back and look at the bigger picture on the Windows app ecosystem. So most people are familiar with the Windows Platform SDK, which provides APIs that are determined by the version of Windows that's installed on the machine. If you want to call newer APIs, the user needs to be running on a newer version of the Windows OS. We also have the Windows App SDK, which provides APIs that are determined by the version of your application. We lifted the modern app stack into your specific application and created your own virtualized instance. If you want to call newer APIs, your app uses a newer WinApp SDK, the same as other libraries and components, and you can tell the difference. Microsoft.star APIs are part of the WinApp SDK, and they're determined by your application. Windows.star APIs are part of the Platform SDK that's determined by the OS installed on the machine.
So what you're saying is that the app developer has the control over what API they want to use.
Yes. So with WinApp SDK, it enables incremental adoption. This makes it easier for larger apps to modernize in piecemeal updates and to integrate different modern content together. WinApp SDK prioritizes predictable consistency. This provides the latest Windows app functionality everywhere from Windows 10, RS5, and Server 2019 upward, without any OS servicing, without IT admin updates, and it's fully side-by-side. WinApp SDK also supports apps choosing the timing for updating to newer WinApp SDK releases. Devs get a new WinApp SDK update, they can validate their app, and then explicitly decide when to move forward.
So I've heard questions like app must be packaged or MSIXed, or it has to be installed to use Windows App SDK. Is that true?
No, that's not the case. We recognize that developers don't want to rewrite their app installers. So what is this all about? So let's talk about packaging. Packaging and using MSIX makes it easy to use WinApp SDK, but it's not required. Unpackaged apps can use WinApp SDK both as a framework package and as self-contained. They're both fully supported and documented on learn.microsoft.com.
So it's great to hear that I don't need to have my app packaged or published to store.
That's correct. We're using it here because it's easier and it has other benefits. One of those is that it gives your app identity. We know that the Windows knows that your app is your app, and no one can impersonate it. So the shell knows the app, and that's needed to be able to call certain APIs like share target and notifications and other things. It also has better per application privacy and security controls in the latest version of Windows 11. So as an example, Teams, which recently moved to packaging, now shows up as an explicit app for things like microphone and camera and location settings, and isn't lumped into all the Windows applications on the desktop. Finally, packaging gives your app measurably faster install times, totally clean uninstalls, and it's great for being able to manage dependencies. It's also great for like end user features that I use for like being able to move which partition my app is installed on to free up space. So we're going to use packaging in our demos here, but it's not required. So with this, let's actually give a demo of using WinApp SDK APIs in WPF. So as part of this, we're going to take our WPF app, we're going to go make it packaged, and we're going to go call stuff from WinApp SDK.
And we also want to get the calculator to stay on top so that I can multitask. So let's use App Windows Compact Overlay API to do that, like the media experience.
Yeah, like the video. Your window stays smaller and on top, and it's pretty easy to go do. So in this case here, we'll switch back. So we have our app where we left it before, and the only thing that I've done is I've gone and done a few of the steps, honestly, to save on compilation time and stuff like that. So let's walk through what I did. So the first thing I did is I went and I created a package. So This is as easy as just go new project, and on the templates, I go packaging C#. And I want to take a Windows application project for C#. That it's UWP and desktop just means it's supported in both. So I would then go click next. I'd then go and say calculator, I can't type, package, and then I go click right. And so then it's that simple. I now have my package. So then what I do is I go and I add a new project reference. And in this case, I reference my application that I want to start when the package is launched. So this would just be my calculator demo app. I also go and for my app itself, because I'm going to use WinApp SDK, I want it to have a minimum bar of Windows 10 RS5. So let's go and do that. So I go to the project's settings, and there's the target OS version and the supported OS version. The target OS version determines which version of the platform SDK I'm going to use. So in this case, I'm using Windows 11 because I want to be able to optionally use all those APIs. But the supported OS version, this is the minimum version that I need. My app's going to run just fine on RS5. So I go and I mark it as version 17.763, which is RS5. I'm also, because I want to distribute my app packaged, one of the things that's good is that we only want to download the hardware platform that's on your computer. So if you're on an ARM64 processor, there's no reason to download the x86 and x64 binaries. So I'm going to go and I will, can't see. Where did I go? Configuration Manager. Oh, there it is. There's very bright lights, so it's sometimes hard to actually see up here. So I can see I've gone through and I've cleaned out the older AnyCPU and the 32-bit ARM options. And I created things for ARM64, x64, and x86. And then I've gone and set everything up here. And then the part I always keep forgetting, but I actually remembered this time. The very important part. So I go to manage the NuGet package for the solution. And I go and I bring in Microsoft Windows App SDK, and I'm going to set it on both my project and on my package. And so this will then go and configure the MS build steps so that I can go and reference all the WinApp SDK APIs in my project, and then that my package is then going to take a dependency on the framework package to automatically deploy it for me. So, and then with that, I've now changed so that the default, the thing that I'm going to run is now the package, and running on the local machine.
And with this, I can do multitasking, like I could have a document and I'm calculating while...
Yeah, we haven't actually called the WinApp SDK APIs. It just looks exactly the same.
Oh,
so
okay.
all that we've done is, yeah, we keep getting out of order and everything. But it looks exactly the same, but it's now being deployed packaged. So now let's go do the part that I always forget, and we'll go call the WinApp SDK APIs. So for this, I'm going to go and WinApp SDK, in this case, we haven't done anything to explicitly bridge it to WPF. This is just calling the raw APIs directly. It can be used from any framework. So your pure Win32 app, Qt, MFC, WinForms, WPF. In this case, we're just using it directly from WPF. So we first need to connect WinApp SDK to my UI thread. And we do that with the dispatcher queue controller. And that gets everything connected. So I'm going to go and add that existing item, and I'll go and add that in there. And then I'm going to go call those compact overlay APIs. So in this here, I can see I've created my event handlers. We'll go and connect those up in a second. And then I just have this worker function that's going to go to enter and leave compact overlay. So again, I need to connect WinApp SDK to my existing top-level window. So from app window, I just go and get an app window from my existing WPF window. And yes, it's a little bit verbose, but that's just because we didn't do any explicit integration. So this can be, you can create an app window from any Win32 window in any framework. Then for when I enter compact overlay, I'm going to change some things around in my WPF layout to make it a little bit smaller. And then I will call the app window APIs with settings set presenter to go into compact overlay and resizing to be a little bit smaller. So the thing is though, like I didn't have to do any DLL imports. I didn't do any COM interop. I didn't go and do anything. Like this was actually pretty straightforward, and I'm doing everything from C#. To exit compact overlay, all I do is I just change the presenter back to default. So let's go and add this in. All right, we'll add that there. And then I'm going to go add some markup. And that's just adding my menu item. And then this is my updated WPF layout that I'm going to use when I'm actually in compact overlay. So let's go compile and run that.
Yeah, I was so excited to see this update that.
Yeah, it's pretty cool.
Yeah, it's very cool.
Okay, so I have my app, and now I have that new compact view menu item here. And when I go and I do that, I can see I'm now in compact overlay. The window's staying topmost, and I can use my apps the way I would normally do. And when I click restore, the window's completely restored back to where it was before, and I'm away to the races. So. So with this demo, we showed how easy it is, without any extra assistance, to be able to use WinApp SDK in WPF. It's easier with a packaged app, but it also fully supports being unpackaged. Packaging does enable system APIs that are really good. It makes it easier to use dependencies and easier to install and get updates. The key thing is, if you're going to use WinApp SDK, is you need to target for Windows 10, RS5, and later, and that's build 17.763. So, and later. And then you target x86, x64, and ARM64, and remove the older NeCPU and the 32-bit ARM legacy ARM. So, and then finally, you also have to add the WinApp SDK NuGet package in your references, and then you call the APIs, and it's that easy. So what exactly is in WinApp SDK? Like let's talk about that. So WinUI is definitely part of WinApp SDK. But we also have lots of other things in there. And so we have widgets and app lifecycle so that you can get better power management and integrate with your app. We have this really interesting scene graph thing that we're going to get to, and I smell a demo coming up. And then we have the Windows Copilot library that we just announced on Tuesday. So this is new at build. So the Windows Copilot library in Windows App SDK makes it easy to use to develop AI on Windows. And it has over 40 optimized AI models that are optimized for your specific hardware. The first wave is going to be in June with WinApp SDK 1.6 experimental. It will include things like Windows Studio Effects, live caption translation, the Phi Silica small language model, recall user activity, and OCR. And it also includes support for PyTorch, web neural network, and everything is powered by DirectML.
So is there any another sessions that they can go learn about this?
Yeah, so honestly, like the best place to start was actually Tuesday's keynote that was really exciting, and you can catch the recording, but you also can get more information on the Windows blog. However, I am a UI developer at heart, and so I really want to use that WinApp SDK scene graph to make your WPF and WinUI apps really great.
Okay, let's do that then.
Okay. So I have to go and load this project. All right. So in this case, what we're going to do is we have a C++ project, this Petzold era. All it's doing is calling WinApp SDK APIs. There's no UI framework at all. There's no WinForms, there's no MFC, there's no WPF or WinUI. It's just raw to the metal WinApp SDK. And so we can see, in this case here, I'm, again, creating that dispatcher queue controller that we saw in WPF. In this crate, I'm creating a new app window instead of taking an existing one that my app already created. And then I'm going to go run it, and I've gone and I've put a little bit of content inside it. And so let's go and try this out. All right. So I have my app, and I can see, in this case, remember, Petzold era, very simple. I am drawing some squares wherever I click, and I can drag them around. And this is really great. I didn't have any UI framework involved.
That's great that you're running without any UI framework, but can you do something with these squares?
Okay, well, the first thing I want to do is let's actually do the same thing in C#. So the code looks exactly the same. I've just changed the package to be the C# version, and
yeah, it's great that it's now running in different language, but can we do something about these squares?
this was really good. So, okay, so what I'll do is instead of putting my squares in, let's maybe put something else. So how about we put some Lottie in?
Yeah, Lottie is a JSON-based animation format widely adopted by the designers. And we also adopted this system-wide through taskbar and to introduce a lot of library icons.
Yeah, so it's a key part of the Windows 11 experience. And I'm actually showing it here without any UI framework being loaded at all. So
it's getting there, but can we see this in some kind of UI framework to...
How about I put it in my WPF calculator? Would that be good?
That's good.
Okay,
That's good.
Let's go do that. All right, so we're back here in the WPF calculator. Yeah, okay, great. It's all showing up here. And so what I'm going to go do is I'm going to go add a couple more things. Again, there's no explicit WPF integration here. This is just calling the WinApp SDK APIs directly. So in this case here, I'm going to go and add stuff to my main window and a few things, and we'll talk about what each of these are doing. So the first thing in this particular case, for being able to connect external content in, WPF wants me to use an HWind host. That's required on the WPF side, but our modern scene graph is completely composition-based and uses visuals. It doesn't require any HWinds. So, but I'm using that because it's used on the WPF side. And this is just standard WPF HWind interop code here. I then have the same code that I showed in, or that I would have shown in my C# demo to actually go create Lottie. This is using the Community Windows Lottie toolkit, and it's going and creating a Lottie island, and then going and, again, connecting it all up in that. I then, again, have some markup, which we'll use to be able to connect it to a menu item. And then in my main window, I'm going and for the thing, I will go and create my island host, the HWind host that the WPF uses. And then I'm going to go create that Lottie island. I'm going to connect them up together, and then we'll try this out.
Can't wait to see.
It's getting good.
Yay.
All right. So create Lottie island. Lottie in WPF.
That's great. So I can imagine using the animations in existing WPF app that I may have.
Yeah. And one of the things to remember is that, let's see, we'll go back here. And so this is, again, our server 2019. And so everything that I'm doing here, like this is the latest version. We made a whole bunch of fixes in Windows 11 to add features and performance and fix things for Lottie. This wasn't possible on Windows 10.
No, this didn't exist
back
then.
And definitely didn't exist on Server 2019. Mm-hmm. So that's getting pretty good.
Yeah.
Okay.
But I want to see more.
Okay. All right. So I'm gonna just check where I am. Okay. And in this case, I'm going to go back to thing, and instead of this, okay, I'm going to go here, and I'm going to go to WinUI Gallery. I have been working on something, and we're going to load this up, and I'm going to go load that island in there. And then here's Lottie, and helmets, 3D rendering. We have a full 3D engine that is used to power WinUI. So this has existed for quite a while, but it hasn't been part of WinApp SDK. And so I needed to use the latest version of Windows 11 in order to get all this functionality. But this gives me everything is rendering the same on all 1.5 billion Windows users today. And let me show the code here. So, because you've never been thrilled about the helmet, so maybe,
Yeah.
okay.
Yeah. Show the code.
Okay.
And
So
explain.
okay.
Yeah, please.
We talked about this a bunch. So in this case here, the thing to realize is that here's the code that I actually have that's going and loading that helmet. And it's all in C#. It's going, and you can see it's creating the animation that was doing the spinning. It's doing some file loading here to go and load the assets. But this is actually like surprisingly short. The equivalent, it would in DirectX, I'd have to write probably about 1,000 lines of C++ code. And it's actually pretty complicated. And this is handling all the hard things of managing and sharing a D3D device across different content providers. It's handling all the stuff with Multimon and HDR, variable refresh rates, having really efficient battery and animations and everything. And it's actually really easy for me to go create my own custom content. So where would we actually use this? And so if you look at a typical app, let's take like Word or Excel, then you use WinUI or WPF for things like your menus and your dialogues. But there's usually a part of your app that is custom content that you want to be able to go and create your unique content and all that. And this is making it very easy to be able to go and do that without having to be an expert C++ DirectX hardcore developer. And it just works.
So what you're showing is that it can be as powerful as the 3D helmet, but it can also do some practical things to put the custom content that you have written thousands of code already.
Exactly. So with this demo, we showed using WinApp SDK in raw C++ and C#, Petzold era application with no UI framework involved. We showed the scene graph that powers WinUI can be used from any framework and in any Windows app. And this allows us to get things like Lottie, the 3D scene nodes that we saw, creating my own custom content, all running down level to all 1.5 billion Windows users where they are today.
Okay, let's wrap it up because we're out over time. But today, we learned that WinUI is a great choice if you don't know where to start or don't have any current code base that you need to maintain. WinUI allows your app to be both visually and functionally to Windows system. And if you need to support multiple languages or CPU choices, WinUI will be your choice. Choosing WPF will allow you to continue investing in Windows with rich ecosystem on a much more stable platform. It will allow you to work with great C# support. You also learned either option you choose will allow you to take advantage of Windows App SDK without rewriting your whole entire app. And both WinUI and WPF have great ecosystem support you need to make your application creation easy. As I mentioned, WPF being a richer of the two today, but WinUI growing.
So now we want everyone to go out and build Windows apps. Please give the updated Visual Studio workload a try with WinUI. Apply new theming with .NET 9 Preview 4 to your WPF apps, and find great places where you can use Windows App SDK, and please share feedback with us. We really do want to hear it. Don't forget to try out the WinUI and WPF galleries as a great starting point.
And we also want you to join WinUI community call that's happening on June 5th. We will have the recap of build, and we are inviting the WPF team as a guest to have fun together. So please come join us. And check out our updated Dev Center. That's where we will be sharing the latest information with you. And here's the links that I promised earlier.
So the BRK 248 talk from yesterday also showed where to use AI and Windows apps using WinApp SDK. And then we have the BRK 244 talk that's happening tomorrow that is going to be with Niels and Rajesh and Pankaj, where we're going to be showing WinUI and WPF in more detail. So we hope to see everyone there.
Thank you.
Thank you so much.